So one thing that's kind of nice about Excel is sorting. And this is one thing that you can do in Excel. It's all right. Let me not select all of those. So let's sort by grams. And one thing that's kind of nice about Excel is that you can see that all of the null values sort of get popped out to the bottom. And then another thing to sort of get a visual look is conditional formatting. And we're going to do a color scale. Don't need a percentile. So the takeaways from this are to always copy your original spreadsheet file and work in the copy, or work in a separate sheet is fine too, but don't modify things in place. Always make a copy. Data validation can prevent you accidentally entering some sort of invalid data, and use sorting to check for that. And then you can use conditional formatting like this in order to kind of check for invalid data, which we'd already sort of popped it all out of the side already. But because if you're using a heat map like this, or like a formatting like this, if something wasn't sort of in that red to blue scale, it would pop out. So to close, we sort of already have exported CSVs a few times, but that's an important thing to know how to do. We don't recommend to store data in Excel files. It's a proprietary format, and so it's possible that in the future that technology won't exist. Excel may not exist in the future, or we may not have access to it, or it will become sufficiently rare to make it inconvenient to open these files. Other spreadsheet software may not be able to open files saved in proprietary Excel. Different versions of Excel may handle the data differently, leading to inconsistencies. And now these days, more and more, journals and grant agencies are requiring you to deposit your data into a data repository, and most of them don't accept Excel format. It needs to be in one of these formats we're about to discuss. The above points also apply to other formats, such as the open data formats in LibreOffice or OpenOffice. So these have a file extension called ODF, which is a data file or open data format. We don't like to use those either. They aren't static. They don't change, or they aren't static. Those change, and even though they're open source, they're still a binary data that has metadata built in to the file, and we don't need that for doing raw data once it's organized properly. As an example, you remember we talked about the dates, and so there's multiple defaults on different versions of the software, and you can switch between them. And so storing data in CSV is universal. It's absolutely open. Everybody everywhere can open, everybody everywhere on the planet that's using a computer can open up one of these CSV files and get the exact same data out every single time. And so there's some notes in the lesson about cross-platform operability and line ending stuff. You can read that if you're interested. I'm not going to go into that now. But if you end up working on OS X and Windows computers, or also are doing things on like scientific compute clusters that generally run Linux these days, it's something you may want to be aware of. And so there are some R packages that can read in Excel files and even dig into the different worksheets, but some of those only work on Windows. And this replaces like a simple export to CSV with extra dependencies that the people you're collaborating with may not have access to. And all of these best practices will still apply in order to get the benefits that we're gonna learn about this afternoon in R. And there isn't really a good argument not to do this. And so one thing also to keep aware of with the CSVs which I'm going to open in LeafPad, is sometimes the data that you actually have may have commas in the text. So you may have, under species, you may have kangaroo, rat, comma, type G. I don't know. Just made that up. And so we didn't see any quotes in this data set, but if you have a comma inside of quotes, it is not interpreted as a new field in your data. And so you can do it like that, or there's also what's called tab separated values files, which I will save this as. .tsv. It's not giving me the option to do that. Now let me open it up. File. I'm forgetting how to do that part because it's supposed to give me a choice. To set that up, but it might have saved that in a data structure somewhere. So even though I can't show you, be aware. You can use tab separated. You can use any separator that you can imagine. Any character that you can imagine. You can do, what is it? Open up a LeafPad. So when you're doing separators, you can do comma separated. You can do tab separated. You can do pipe separated, which this is above, if you press shift above your enter key. And pipe can be nice because it's not used very much in anywhere else. And so it can be something that if maybe you have tabs in your data, maybe you have spaces in your data, maybe you have commas in your data, pipes might be a good separator to use. I guess questions, comments at this point, and we're about to move into OpenRefine. So we have like survey data, spreadsheet cleaned. I'm going to delete that one because that didn't work properly. So that's what the README would be for. And then, so this one's surveyed data spreadsheet cleaned. And if you wanted to be really clear, put a date and just say like May 16, 2018. And that just depends on what makes sense to you, what makes sense to your project. It's good to date things, and also on your like if you do view folder view detailed list view. It'll like your operating system will generally keep track of the last time you modified a file. So if you just keep adding new and just call it A, B, C, D, or just, I mean, even add like random characters at the end to differentiate the files, it'll still keep track of whatever you touch last. Your operating system will do that for you. And that's usually how I keep track of my work, is by using the operating system that keeps track of when I modified files.
So let's say you just opened up the previous copy of it. Would it consider that as modified if you just opened it and closed it?
Depends. Like, it depends on if you did a save operation on it, generally. So like, what is this? This was modified at 7:49, which mine's an hour off. So like, we open this up and then file save, and then it updates it. But then like, take this and just open it, and it doesn't update it. So you'd actually, it's whenever you saved it. So even if you didn't change everything, if you run a save operation, it will update that modified. And again, it might be a little bit different on Windows. Windows might also auto-save sometimes. Anything else? Cool. We're going to do Open Refine now. We're going to take about 5 minutes to get switched over. All right, so Open Refine is really cool. I like Open Refine. But most people have never heard of Open Refine. I mean, who in here has heard of Open Refine? Besides, who did I talk to about it this morning? Yeah, I talked to you about it this morning. So Open Refine is a Java program that runs on your machine. It actually runs a web server on your computer, and then you interact with this program through the browser. Excuse me. This is not running in the cloud. This is actually running on your machine. If you want to find out a lot more information, you can go to openrefine.org. Let me pull this over here. There's a Google group. There's a Google Plus community. Open Refine actually used to be called Google Refine, but then they open sourced it. And so this is Google's internal data cleaning tool that they have since released. So the thing it's good for is it's open source. So its source is on GitHub. So you can look at it and change it. And if you need it to do something that it cannot do, you can skill accepting, add that yourself or hire someone to add that for you. There's a growing community, and it works with kind of large data sets, like 100,000 rows. It does not scale to like many, many millions yet. And one thing that's really cool about Open Refine is that it tracks any steps that you take working with your data. So you can sort of like as an undo list. So it doesn't modify anything in place as you're working with it. It sort of keeps track of all those steps. So you can always back up if you make a mistake. the word for that would be munge, which stands for mash until no good. So M-U-N-G. So if you munge something, you can unmunge it using Google Refine or Open Refine. Yeah, so the first thing we're going to do is create a new project. So start the program, launch Open Refine. It'll automatically get everything up and running and should automatically open in your browser. If not, you can go to 127.0.0.1 :3333, which is where it'll run that server. So we can grab a lot of different types of stuff, but we're just going to click on Choose Files and navigate to where you saved that CSV, the Portal Rodents 1977 to 2002, and then open that file. And all that'll do is set it in here to load, and you click on Next. So this is the actual data. This is real data. The stuff we were using before was kind of a simplified subset of this data set, which apparently in ecology, this is like one of the earliest big open data sets that was published. And so that's why this is being used. Software carpentry started by biologists because no biologists are trained how to do this coding stuff. And so that's why they started it. I'm a social scientist, so. And so kind of look through, and that looks pretty good. Like, I mean, there's like the survey ID, month, day, year. I don't know what the period stands for right now. A bunch of different plot IDs that are big old hash function things. Plot, note, stake, species, and then the full scientific name. And then a long description of where the sample was taken. But it looks pretty good. If you click, you can kind of see how things might break. So if you see this, you know you're going to want to mess around with this parsing functions down here if you see something like this. And you can see it can read CSVs, it can read TSVs, or you can set whatever delimiter. Okay, that looks good. So I'm going to click on Create Project up here in the top right. And now this is kind of the live data, the live view.
So we click on Create Project?
Mm-hmm. If it looked right, which it should pretty much automatically. So the core metaphor here in Open Refine, which you can see the logo is this gem, is faceting and filtering. And so facets groups like values in a column and then allows you to filter data by these values and then edit values across many records at the same time. So one type of facet is a text facet. And so if you click this little triangle next to scientific name, it'll have a drop-down box. And so we're going to do a text facet. So now in this left panel, you'll see a box that has every unique value in scientific name. along with a number that represents how many times this value occurs in this column. And so you can sort the facet by name, or you can click on count to sort it by the numbers that you see, by the counts of that name appearing. So if you hover your mouse over one of the names in that facet list, you can see you can edit and edit that along that edits every single instance of that value. And you could use this to fix errors immediately, and OpenRefine will ask. So you can edit this, and I'm just going to add an A at the end. And it does a mass edit. But I don't want to keep that, so click over on Undo, and then click back. And you can see that it keeps track of every change that you made. So you can see that there's some typos. I mean, there's inevitably going to be typos and mistakes. Like, we're people, not machines, and so we do make mistakes. And so you could go in and fix those manually now that you see them. But there's some algorithms built into OpenRefine that can do this kind of stuff automatically. And that's kind of the next step. So as well as text facets, Refine also supports other types of facets. You can see there's numeric, there's timeline, there's scatterplot facets. Numeric and scatterplot facets display graphs instead of lists of values. So the numeric facet graph includes a drag and drop controls that you can use to set a start and end range to filter the data displayed. So where's the weight? Is that in this? So we have this weight. Let's see what we can get here. Facet, numeric. It may not be in this data set. So let's just do that'll make a graph. Do I need to set it as a numeric value? I must have imported all of those as just text, so we may not be able to play with that way. So anyway, what we're going to do as an exercise on faceting is find out how many years are represented in the census. And is the column formatted as number, date, or text? And then how does changing the format change the faceting display? So I'm going to figure out how to actually switch the columns to numbers.
Edit cells.
Edit cells,
Format.
come and transform. Thank you. And so this actually pulls even though I don't know if treating those record IDs as numbers would be actually terribly useful. But it kind of has a slider so you can look at chunks of data. So using faceting, let's find out how many years are represented in the census. Like how many actually discrete years are we looking at? And then actually do that edit cells and or edit column or edit cells, and then actually transform them to numbers to dates. And so you notice that attempt didn't actually turn any of those into dates, but they're not valid dates. So it didn't blindly drop these into something. It actually checked to make sure they were dates. But I am going to turn those all into numbers. So let's facet year, and I'm going to do that as a text facet. And so that tells us how many years are represented. Let's see what a timeline facet gets us. That breaks in an amazing way. So we can answer the question here, which years have the most and least observations? How do I get?
Oh, we're good.
Okay. So this one's relatively straightforward. In order to get the answer, you sort this by count, and you can see that 1997 has 2,493, which is the most, and 1977 had 503 observations, which is the least.
here you did text facet.
Mm-hmm. But then you can also, let's see if we do a numeric facet. You can kind of see a little graph that gives the number of observations in each of those buckets. A histogram.
How do you get to that histogram again?
So that's a numeric facet. So if you have the year, and make sure that you set those as a number. See what happens if we turn that to a text and what happens. So if we turn it to text, no numeric value is present. But if we turn it to a year, edit cells, common transforms, to number. And then do a numeric facet. So this is, to get this, you do year, facet, numeric facet.
Oh, I see. Oh, those are the trends.
Yeah, so the scatter plot facet.
There's no correlation there.
Mm-mm. But sometimes that's what you do. You kind of look at the data and see if there's a correlation.
Right.
Mm-hmm. So year, facet, and then scatter plot facet. Mm-hmm. And that's kind of the trick, is that as researchers doing data analysis, you kind of just play with it. And the point of these tools is that they will automatically keep track of what you did. So once you end up with something that says, yes, this is the correlation that this data has, instead of sort of having a grand design, we can look at the data and then draw inferences from the data rather than, yeah, which is the whole point of data science. So we have this stuff, which is cool and all. But this isn't what makes this really cool. The algorithm that is so cool in here is this button right here, this cluster button. And so OpenRefine can find groups of different values that might be alternate representations of the same thing. So, for example, two strings like New York capitalized, I should say New Jersey capitalized, and New Jersey with no capital letters, they're very likely to refer to the same idea, the same concept, and only have capitalization differences. So likewise, Gödel with the umlauts and Gödel without the umlauts probably refer to the same person. And so clustering is a very powerful tool for cleaning data sets which contain misspelled or mistyped entries. And OpenRefine has several of these clustering algorithms built into the software. So click on cluster. And so what we have in this pop-up window is we have the cluster and edit column. So we can change the method and look at key collision, which is like basically how many of the characters in that alphanumeric string are the same, or the nearest neighbor, or different types of algorithms. Nearest neighbor is a little bit more complicated. If you want more information, I'll put some links up at the end of the lesson on how exactly these work, because they use these different distance functions. which sort of mathematically determines like how far away in a data sphere or whatever metaphor you want to use these different things are. So let's look at key collision, and then let's use the keying function metaphone 3. And then if you think that these are like correct, the correct values, you click these merge boxes here. And then click down here at the bottom, merge selected and recluster. All right, so now I found no clusters with that method. So try using different methods and different keying functions and see what you get. And kind of play with the numbers and see what happens. And there's a lot more to think about here, but it's way past. We're doing a general overview of this. If you want to know more, I'll drop the link. There's some. So the link's at 106. That's sort of the OpenRefine wiki that has some more information about that. And then And then at 108, there's a big link to a bunch of the papers that really go into these algorithms. So this is a rabbit hole kind of topic. And if you feel like diving in, go ahead. I definitely have read all of those papers because this stuff is pretty cool. Oops. Accidentally pressed the back button.
only takes the data with CSV format?
Hmm?
It only takes the data with CSV format or any other format?
You can import data with CSVs, TSVs, and I think there's a few more. I'd have to look at the list. But when you go to so when you go to create project, you can pull in from TSV, CSV. I mean, when it says that star SV, that means any, whatever separator you want. It can pull in Excel. It can pull in JSON, which is JavaScript object notation, which is a way a lot of web developers use that to pass data files around. Structured data. XML. RDF is XML, which I don't remember what that is off the top of my head. Google Sheets, and then there are extensions out there for other data formats. Mm-hmm. So I think that this is probably a misspelling. The Ampispiza silinata, because there's only one of those. So it's probably a misspelling. So I want to merge those. These here, those are probably not a misspelling because those are very different. And so you don't really want to merge those. So let's merge the selected and recluster. Let's bring this block characters down and see what happens. Yeah, see, those don't seem like I'd like to stack those together. Let's turn that down a bit, turn it up a bit. See, and I think those are probably the same, supposed to be the same. So let's bring that down a little bit. Let's try Ingram fingerprint. Not finding any clusters there. So since it's not really finding the cluster that I'd like it to find, we'll get to how to do those edits in a moment. So we can also do a split function here, much like we did the text to columns. And so we do edit column, and then split into several columns. And so here it's a similar sort of operation where we pick the separator, and I added a space there for the separator. It replaced the comma with a space. And let's go ahead and uncheck the box, remove this column. So now we have scientific name 1 and scientific name 2. So if we kind of look through our data a bit, how does that look? Let's sort by that first scientific name. Let's go down to the end. We notice that some of these don't have a scientific name, even though they do have a species listing. So I'm trying to find the right place to look. Which the thing I was expecting to see isn't showing up.
Kevin, what happens if we accidentally delete one row and we want to undo it?
You should be able to click on undo redo.
Yeah, but it's doesn't apply here.
So like if you did edit, so how did you delete the row?
So undo that. Then uncheck the box.
So we just check
I unchecked the box, but somehow doesn't wanna, it keeps asking me like, specify the separator.
Specify the separator. Did you, with the comma, did you make, it's not, shouldn't be blank, you have to actually add a space.
Oh, you mean, like a space?
Mm-hmm.
And then,
Mm-hmm.
oh.
Because a space is a character. It's not just blank.
Okay. Oh yeah, now I have scientific 1, 2, and 3.
Mm-hmm.
And 4, yeah.
No, I thought it was
See, I'm not sure why I don't have 3 and 4.
Yeah, I come out 1, 2, 3, and 4.
I must have already, because of the way I clustered things, I must have clustered all that out.
Oh,
So I'm going to go back actually and undo those mass edits. Those mass edits were the clustering. And so now
oh, you declustered it to,
value to number, value to string. And so now let's edit columns split into several columns, separator space, and then don't remove this column. There it goes. This is the expected error that I was confused that I wasn't seeing. because I'd already clustered that error out. And so this is a sort of odd error. Like we should have had what I had up there before, where we had the scientific name with the first half and the second half, what genus and species. Is that what it is? But we have instead we have 4. So what's the issue here? And so what do you think? What do you think happened? So how can we fix that without clustering? So because that's something we want to fix without it being sort of automatically done with a clustering algorithm. That's something that we would like to fix before we run anything else on it. So go ahead and undo that operation. And then here, we can do edit cells, common transforms, trim leading and trailing white space. And so white space is any character that wouldn't print something like on a typewriter. So like on a typewriter, you press space and it moves the thingy over, but it doesn't actually type something. Or you press tab and it moves it over a little bit more, but it doesn't actually type something. That's what white space is, and that's we're working with old metaphors all the time. Everything we do, we're working with old metaphors. So we do that, and then now let's do the split into several columns again. By that space separator, make sure not to remove the column. And then now we should have 1 and 2. Which is actually kind of interesting that the clustering algorithms trim that white space automatically without really saying anything about it. It's a good thing to keep in mind. So let's try and change the name of this column. Where's the button for that? Edit column, rename this column, change it to species. So we end up, because we already have this column named species, we can't change this column name to species. So column names need to be unique.
I make the S capital letter and then you change it. I use a capital letter of S and then you change it.
That's one way to do it. Like what I would do is I'd probably rename this one to like species code, and then change this one to species name. Just so that the more semantic, like the more information you can put into your variable titles, the better. The more a layperson could look at your data and say, this is what's going on, the better. Okay, so at the very end of this bit, we're going to undo that splitting step. And make sure to undo that so that we only have the one scientific name. Otherwise, it'll change some things that we do next. So next we're going to work with filtering and sorting with OpenRefine. So how can we select only a subset of our data to work with? And then how can we sort our data? And so we're going to do a text filter and an include-exclude filter to filter to a subset of rows. We're going to sort tables by columns, and by a single column and multiple columns. So let's click the arrow here, the down arrow, and do a text filter here. Let's do BAI and then press return. And so you can see that this filter ran before the faceting that we have. So we have the facet that looks at these two from the subset that we filtered. And this gives us 48 matching rows. And there's more than one way to do this. And so this is one, once you've figured out how to filter to one of these species, and maybe a few different ways to do it, throw up a green sticky. So a few different ways to do this, to distinguish between these two strings, is to set it as a case sensitive, which would only match what, I'm not even going to try it, Chetopodus Bailey? Bailey? I don't know. I never took Latin. Or we can add another character to the end. So if we add an O to the end, we'd only match the Biomis taylori. Or make it Bale, B-A-L, and only match that one. So in addition to those solutions, another way to narrow out is to include or exclude entries in a facet. So if you still have your facet for scientific name up here, if you don't, you can remake it. And so faceting and filtering look very similar. A good distinction is that faceting gives you an overview description of all of the data that is currently selected, while filtering allows you to select a subset of your data for analysis. So if you hover, you can see you can also do include, exclude. In your facet. And you can see from the number of matching rows. If you're working with a really big data set that's more than 50, that's maybe thousands of records, paying attention to how many matching rows you have is a good way to sort of guesstimate what you're looking at, like what part of your data set you're looking at. And if you've been poking at a data set for a while, you'll start to know what those numbers mean. So before we continue, make sure that you have both species selected, either by including both or excluding both. Because if everything's excluded, everyone's included, I guess. So we can sort the data in a column by using the drop-down menu available in that column. You can sort by text, numbers, dates, or Boolean, so true-false values. And you can also specify what order to put blanks or errors in the sorted results. So what are we going to sort? Let's sort by month. so you can see this didn't actually change anything, this sort. But it did add a drop-down box up here. And so we have this sort by month, and we can respecify the sort. We can remove the sort. We can reverse the sort at this point. But the sort of thing to do here is that at this point, we haven't actually done anything to change we're just changing what we're looking at. We're changing the view rather than changing the data itself. So as an exercise, let's sort the data by plot, and then answer what years were observations recorded for plot 1 in this filtered data set. And throw up a green sticky once you have that answer. And I actually dropped the exercise there in the Etherpad, which I probably should have been doing this whole time. But it's at line 110. So you can see that in plot 1, they've seen these two little types of mice, one in 1990 and a couple observations in 95. So you can also sort by multiple columns, and the sort will depend on the order in which you select the columns to sort. So you might want to look for trends in your data by the month of collection across years. So let's sort your data by month. And then how would you do this differently if you're instead trying to see all of your entries in chronological order? And go ahead and take your stickies down. And once you're done with that exercise, throw them back up. Yeah, I'm pretty sure that that is numbers. And it may give negative numbers as red. And it also it changes the way it's justified. So it moves it to the right side rather than the left side. So like, say let's transform, or something we can transform. Let's transform all these to capital letters. Yeah, I put the notes that I'm working from on line 102 in the Etherpad, or a link to the notes. Because we have about 15 minutes left. And so we're going to talk a little bit about numbers. And we're going to, but the rest of it we're going to kind of leave for y'all to do in your own time. I think some of the most like important takeaways that I think you should keep your mind on is about the possibility for white space to mess up computer algorithms, because that's something to be mindful of when doing data entry. I think that's a really important thing to keep in mind, even if you delete OpenRefine and never look at it again. That's a really important thing. I also think that the clustering algorithms are really cool and really powerful, and are worth looking into. You don't have to know all the details of an algorithm to use it. In fact, most people who do computer programming for a living have no idea what they're doing. And just stick stuff together and get it to look right in the end. But as long as you know how to communicate what you did to get it to stick together, other people can redo what you did, which is the important part. You don't have to know all the details of a Levenstein algorithm in order to use it to cluster data, because OpenRefine will keep track of the fact that you use that algorithm and keep track of what that algorithm did to the data set so that other people can follow what you did, which is the cool part. So I will show this really quick. So we did all this stuff, and our collaborator is like, you know what? I don't believe you. I don't believe that you got the results that you got from doing your data analysis. I can't figure out what you did. So when you go to undo redo, you can also extract what you did as, and this is JSON, which I'll actually pop it into a text file. And this is really a flat text file that you could drop this into an email and they can copy paste it into OpenRefine, which is apparently what the guys at Google did all the time, to send these things around. And this gives a list of everything that we did. So we did an operation, core, text transform, and then did a text transform on cells using the expression value to number. And then it was a row based and there were no facets involved. And which column did we do this to? What expression, which is like that's like a function being run on that column, which is something that we'll talk about more in R. And then what happens if we run into an error? Do we want to repeat this on any other columns, etc. And then it lists every operation that we did. And if we only want to extract parts of it, we can choose each one of those operations that we did and send that across, saying, here, this is what you want to do to your data to get what I'm looking at, so that we can be on the same page and looking at the same thing. That's why this is important, is so that each of you can work from the raw data and then apply these transformations so that the raw data never gets munged. And I'll leave it as an exercise to y'all later to actually play with that and do it, because then you can paste in and do the stuff. So like we go back to here, and then apply, paste, boom. We're back to where we were. So yeah. But that's something that's worth playing with. And then this is, like I said, this is another rabbit hole. There's a scripting language that OpenRefine has. There's more tutorials. There's a book you can get. You can read about the whole history on Wikipedia, and that's all in the course notes. So we got about 10 minutes for questions, and then we're going to break for lunch. And this can be on anything. This can be on what's happening next. This can be whatever.